Okay, thank you very much, Fabian, for the invitation and the opportunity to share with you what are the latest news about RAPAS. I presented RAPAS during the second and the third Astro-COLIBRI, and I'm very pleased to show you what are the latest results. So more and more French amateurs are joining this program collaboration. This program collaboration is supported by Observatoire de Paris, who funded us particularly to design and manufacture the filters and also two spectrographs, two prototypes. I'm going to show you what are the results. So we got funding since 2022, and last year we got, and this year even we got a fourth funding to manufacture a second batch of filters, and we designed a second version of these filters. So clearly the idea is you have to wonder in your country if such a network of amateur astronomers could be organized. I'm sure that you have amateur astronomers in your country, and really there is a few things to do to create this network and work and then working in their native language and got practice. So we are our concern are in three fields. So detect asteroids, and now the concern is detect near-Earth object coming from the minor planet center. At the very beginning, it was a Gaia-Fun solar system object alert, which was the first motivation. The second motivation is perform the monitoring of optical alerts, and the third field is multi-messenger astronomy. And I would say up to now we have only performed, we had results in the field of gamma ray burst optical signature monitoring. So our up to now we have more than 80 observer, amateur astronomer observer, and of course we have statistics about the definition of all the telescopes. So you see most of the telescopes are 30 centimeters in diameter. We start roughly at 200 millimeter, and we have two telescopes up to 80 centimeters in diameter. The second interesting things coming with amateur, thanks to the short focal length, is the field of view. And so we have now a telescope up to 3 square degrees of field of view. And the interesting thing is the étendue géométrique, so the mix of the two values, the aperture and the field of view. And you see more and more telescopes also are mixing the two data. You have here, for instance, the field of view according to the aperture surface. You see the cloud of point, and some telescopes are moving in this area, which is interesting to recover, so multi-messenger alerts. So here are the map of the location of all these telescopes in France against the sky pollution. And the nice thing to have in mind is, you know, every night somewhere the sky is clear. The coverage, we are able to look at the sky. So you may also consider that we have a permanent capability to monitor the sky, to monitor an alert, thanks to this, how we are spread all over France. So at the very beginning, the idea I proposed to Paris Observatory, thanks to the benefit of the wide spectral band coming with the Gaia catalog, is are we able to use such filters fitted to amateur telescopes to get as last program and also go to you realize that there is a real benefit to use wide spectral band, wide band filters to get as much as possible flux and to enhance the signal of noise ratio and to enhance the magnitude upper limit we may achieve. The other thing is the Gaia catalog is a dream because you got the magnitude outside of the Earth's atmosphere. And so now we are using DR3. End of next year, we will have DR4, which will be a whole sky catalog with more than 2 billion objects. And also the nice thing we demonstrate is amateur astronomers are using several kinds of software, image processing software, Prism, MiniWin, AstroImage, Cyril, Tycho Tracker, AstroPy Suite, STD Pipe, and we demonstrate that this software getting the flux from a picture and reducing it in front of using the Gaia catalog gives the same value. We have a very robust output even when we are using a different kind of telescope and using different kind of software. Thanks to the fact that the Gaia catalog is pure, this is a nice thing. You have to remember that in fact in Gaia there is no filter. The spectral band of the three Gaia bands are defined by the CCD itself, the quantum efficiency of the CCD, and are defined also by Prism in front of the low resolution spectrophotometer, which defines so the three spectral bands. The nice thing is the absolute accuracy of this Gaia catalog. You see are in the range of millimagnitude or few percent of the magnitude up to magnitude 17 and even beyond 20 for G catalog. So we manufacture such filters in a V1 definition with a French manufacturer. And so we define what we call the B filter meeting the GBP specification coming from Gaia, the C filter meeting the GRP, and for the A filter meeting G band of Gaia. In fact, it's an anti-reflecting window, so giving the quantum efficiency of the CCD according to the wavelengths. This year, so we define a new V2 of this filter. We are prototyping such a design of multi-layer coating, and you see the benefit of this new definition to enhance the plateau, the transmission on top of the band, and particularly for the GBP filter, and the same for the GRP filter. And so we intend, if we got funding, to manufacture these V2 filters next year. And so clearly, I'm here to ask you, are you interested, or does your network or amateur community in your country could be interested in such a filter? Of course, according to the quantity, we may decrease the price, the unit price of such filters. So this is a possibility. So when we got the filters, we asked amateur to perform an acquisition in 3 selected area field of view. We have in the sky. It was a publication in the 80s we got in a Skyan telescope. Here, for instance, a picture I've made with my telescope in such a field. And then with the 3 filters, we check what is so the limiting magnitude we may achieve. So you see here in G band, I'm above magnitude 20, nearly 21. In GBP band, it's the same. It's maybe even better, thanks to the fact we reject the night glow. And in GRP band is a little less, but in fact, we see that we are much more sensitive in that field, but the quotation of the magnitude of the star are a little less. Okay, so, and here you see the first reduction we perform giving the magnitude we extract from our image processing software compared to the Gaia catalog, and we see a very strong agreement, very nice fitting between the measurement and the Gaia catalog in the 3 band, and even we noticed here, for instance, stars brighter than in the catalog. In fact, we are detecting new variable stars, and so this is and the same when we to show what is the standard deviation according to the magnitude, and of course we detect how this standard magnitude is increasing with the magnitude of the star. So in 2023 we started to monitor. It was a supernova in Messier 101, and we started so with a few first telescope, the first operational telescope of the network to monitor the supernova, and very quickly we realized that all the data are in coherent according to the time, even for data coming from a different kind of telescope. And also we were able to draw the color index GBP minus GRP versus the magnitude, and to show how the supernova was cooling according to the magnitude of the supernova. Here is 2023. Yes, it's the same supernova. We were able to follow it even more than nearly 1 year later, and you see the color index here. So last year we achieved an agreement, a partnership with Astro-COLIBRI, and Fabian Schussler so proposed us to filter Astro-COLIBRI alerts, to provide us only 10 alerts a week, and every Friday we receive a message. And from this message, we understand what are the selected alerts for the coming week. Either they are new alerts or alerts we were monitoring during the previous months, or even for a longer time. And we also introduce a poll functionality. So according to the observers, their availability, the field of regard available, they can tick the alerts they will be able to follow the following week. And so also Fabian is able to see if some alerts are not followed, and so he cancels it and he replaces it by new alerts. So a very efficient way to concentrate all the observers on a limited number of alerts to follow it week after week. And then also last year, I introduced a spreadsheet, Google spreadsheet, to allow observers to put their data in this Excel file, and to be able to draw at once the light curve of any alert. And of course, also nice things coming from the last workshop, Astro-COLIBRI workshop, was the ability to Astro-COLIBRI to read this value and to share it in Astro-COLIBRI forum. Here you see one of the supernova we follow at the beginning of this year, and it was SN 2024 COE, and again with the light curve in the 3 Gaia band and the color index we got. And here is the harvest of last year of all the objects we follow. So sometimes we only deliver an upper limit, a magnitude upper limit we didn't reach, but well, or we have some dot or a complete light curve through several weeks. And so here are one of the first GRB we recover, and thanks to the help of Fabian Schussler, we started to release GCN circular, thanks also to a previous workshop where I met the team of GCN at NASA, welcomed me to issue GCN. And here is the latest GCN I published. It was on Sunday. It was a gamma ray burst which was detected on Friday. Friday night, we got, in fact, you see 6 measurements on this field of view with some successful measurement or upper limit measurement. And also for the supernovae, yes, it was SN 2025 COE. In June, we published a TNS. So that's work. The network is working, delivering data and to the community. Michel Denfeld from Institut d'Astrophysics de Paris at the very beginning also told us, well, your team is very interesting, but we need also spectral data, SED on targets. And so that's what we have done in the last years. We developed so 2 prototypes of spectrograph, very low resolution, high sensitivity, high luminosity spectrograph to be able to deliver SED. And so we manufactured the ALP200, you know, in the amateur community, we have the, it was created maybe 10 years ago, we have the ALP600 using a 600 groove per millimeter grating. And we replaced the grating by a 200 groove per millimeter. It was a GRISM coming from UK. And we manufacture also a prototype, we call it the Solex. It is a product defined by Christian Buil. At the very beginning, this device were using 600 or even 2,400 groove per millimeter, and we replace grating by 150 groove per millimeter. And we were able also to replace the focal, to reduce the focal length of the collimator to fit a high aperture telescope to enhance the sensitivity, to enhance the luminosity of this spectrograph. And here are the first results we got last year and this year with these 2 spectrographs. And we showed that with, you see a celestron 11, so it's a 28 centimeter diameter. Robin Leadbeater in the UK achieved a spectrum of target at magnitude more than 18. It was, yes, the supernova was 18.6 in magnitude, in our magnitude. And here is ALP200. We test on the 600 millimeter telescope, the telescope Jean-Marc Salomon. And we demonstrate the sensitivity. You see, in only 180 second exposure, we got the spectrum of magnitude 15 nebula. And with the star X also we show so the order of magnitude of the magnitude depth we may achieve is about we realize that with a 40 centimeter telescope with 1 hour exposure with a good sky, we are able to reach magnitude 20, in fact. So it's very impressive. And so the purpose is clearly next year to get some funding and to purchase 5 or 6 of these 2 family of spectrograph and equip a few telescopes with this device to deliver SED when it's worth, according to the line curve, to get a spectra or to provide, to help to characterize and classify the alert. So clearly you are welcome to join the RAPAS network, but I would say you are welcome to support such a network in your own country and maybe establish such a connection like Lukáš introduced with this network of a small telescope and amateurs through Europe, or even this could be worldwide. Also, we invite all the observers in the RAPAS network to join the HTOM and to join also kilonova catcher. This could be very interesting, and several circulars have been published with the observer we got. And so clearly for next year, what we would like is strengthen the collaboration with professionals, and particularly we need guidance, we need a target, coordination to focus on some events. Clearly, we have to be plugged to the Vera Rubin outputs now, and maybe this is something we have to prepare, Julien. So clearly we have to enlarge this network and maybe to connect such a network between countries and to have such a coverage to cover in longitude and in latitude all the alerts. And so clearly, so we would like to introduce this capability, so to provide the SED. And what we are working also is, so today we have only the spreadsheet with the data, but clearly we would like to allow the amateur to upload their feeds and allow you to perform data mining and got all the feeds attached to an alert and allow you to do your own processing. So that's it, I'm finished. Thank you very much.